All right, so welcome to today's session. Okay, so today we are going to be focusing on this topic. Okay, I don't know, are you able to read what I'm writing here? Can you read this? I know my handwriting is terrible, but I want you to read out this. Okay, have you seen this topic? This is what we are going to focus on today.
I can only
What is this?
is it
You see my
expression?
terrible handwriting.
Yeah, I've seen it. I can only see
What is it?
expression. I think
You can see what?
I would
Expression?
is it express yeah, expression.
Expression. You can't see this word.
Yes.
Okay, maybe let me try to write it better. Okay, so this is the thing, eh?
Algebra.
Yeah.
Algebraic.
So algebraic expressions. So that is our topic today. Okay.
Yeah.
So now, the method of learning that we are going to use, uh, will be basically be guided by questions. Okay, so we'll start with the latest. This paper is November, the latest paper that was written 2024. Okay, it was written on 6th November 2024. This is the paper one that was written. Okay, so question one was on algebra. Okay, so now this is the question. It says simplify 3 open bracket 2x minus 4 close bracket minus 2 open x minus 1 close. Okay, so this is algebraic expression. Okay, and
Yes.
without wasting much of the time, let's go into it. And you have to at least participate and solve this question with me, so that you hopefully you have a pen with you. You need to be solving as I'm solving, and in fact you have to be ahead of me somehow. In case you make a
Wow.
mistake, you'll be rubbing. Okay? You
Okay.
have a pen with you?
Yes.
Okay. So are you ready?
Yeah, I'm
Let's go.
ready. Okay.
Okay. So here, this is easy. Okay. So when you see brackets, it simply means we have to multiply. Okay. Like, we have to use the when we say 3 open bracket 2, this is simply means we have to multiply 3 by 2, which will give us a 6. Okay, this is the concept we are using. But what if we've got 3 and in the brackets we've got variables, like maybe terms that are combined with variables? So we are going to see how that works with this for the signs that we have. Okay, so now let's go ahead and deal with this. So now here we are going to now expand this. Okay, you see that? What are we going to get when we say 3 multiplied by 2x?
So 6x.
We are going to get
6x.
6x.
Yes.
Yes, and here when we, okay, what number is followed? Like what number is do we have in the bracket again? What number? I'm interested in that number. Which number is that?
4.
Do we have 4? Are you sure?
Wait, at first you said like
I-
which is in the
Is
bracket?
this 4? Is this 4?
Negative negative 4, sorry.
Yes, negative 4. Do you know the difference between 4 and negative 4? You know, algebraic,
No.
we deal with integers. Yes, let me show you the difference. Let me take you back to number line 1, 2, 3, and 4. Okay, we have negative 1, negative 2, negative 3, and neg 4. Okay, so
Yes.
I want you to look at the difference which is there. Sorry, what am I writing? Okay, so I want you to see the difference. There's a difference of 1, 2, 3, 4, 5, 6, 7. There's a difference of about 7 digits before you get to 4 from -4. Have you seen? Have you seen the difference which is there? From here
Yes, I've
going there. So you say we've got 4. There's a bigger gap here, you see? So we don't have
mm,
4. Yeah. So someone who says no, we've got 4 here, and someone who says we've got 2. Someone who says we've got 2 is even much better because they are close to that. Okay, you see,
yes.
and just even -1 and 1, there's a difference of maybe 2 here. You see, you get the point.
Mm,
Is it making some sense
yes,
to you now? All right.
yes.
And hopefully you know the name of your mathematics tutor. Do you know him? I introduced myself if you can remember my voice, if this is the same voice you were talking to last night. Okay, so do you know my name?
No,
You don't
no.
know the name of the person who's teaching you. Okay, anyways, Ndinewasa. Right. So
That's that's that.
3 Ndinewasa Mwasa. That's what people who teach, that's how they are called. Oh,
Oh,
Wasa. Wamdani. That's how they address people, right? you know okay, okay, fine. I'm just joking. Okay, I'm Mr. Kachingwe. All right, so that's the thing. So now we proceed. 3 multiplied by -4, what are we getting?
-12.
-12. Okay, so how did we arrive at -12? So now what I'm saying, we are going to be guided by questions. So from just solving this question, we are going to deduce a lot of concepts from this that are used to deal with algebraic expressions. Okay, so it's interesting. So the rules of algebraic expressions, they go like this. Okay, positive
Mm,
plus or negative plus negative is equals to negative. Is it
yes.
true or false? No, it's positive.
Oh, so yeah.
Positive.
Can you-
uh Ah, okay.
Are we not supposed to use the times?
Positive. Okay, let me just write some rules that will guide you instead of writing positive. Okay, let's say same signs. Okay, same signs. Okay, like when algebraic expressions are the way we do the way they're like this. Let's say positive times positive. Okay,
Yes.
what are you getting? You are getting a positive, right?
Yes.
Negative times negative, we are getting a positive. But negative times positive, we are getting a negative. Okay, so same signs, when they multiply, they will give you a positive. Same signs, this is what this means. So now, when you've got different signs, they'll give you a negative. That is what it means. But then there's also, when it comes to when you're adding, okay, let's say you want to say -1 plus 2. Okay, the answer is what? What's the answer? The answer is
The answer would be positive 3.
positive 3. No, it'll be +1. Am I right?
Yes.
Number line.
Um,
Should I take you to number line? All right. So
no.
here's a concept you are getting from this. Here's a concept you are getting from this. Okay. So get it clearly. So the concept that we are getting from this is, if you've got different signs, just subtract and get the sign from the bigger number. So get that. You can write it somewhere. Different signs, subtract and get the sign from the bigger number. Write it somewhere. If you've got
Different.
different signs that are, we are talking of negative and positive, that's all, okay?
Yes.
Don't add multiplication and division. We're just talking about these ones. So in a case where you've got different signs, just subtract and get the sum from the bigger number. So this is as good at 2 as 2 minus 1. You just get in, don't confuse things, okay? 2 minus 1 is equals to 1. Okay, we've gotten the sign from the bigger number. Here we cannot show a positive because, there's no any number before these two, okay? Unless
Yes.
in this format, because these two expressions, they are the same. That is what you need to know, okay? So
Yes.
the bigger number, we always get our sign from the left side of a number. So this 2 is holding a positive sign, which is hidden, which we cannot show there because it is irrelevant, unless it was on the other side, like the way it is there, because we cannot write, if we exclude the 2 here, it will not, if we exclude that positive, it will not make sense. So if this 2 had a negative, we would have shown it there. But regardless, if it has a positive, we still have to show it. You see, is it now making
Yes.
sense? So there's another concept that I want you to know, okay? Negative
Yes.
1 minus 2. What is our answer?
Our answer will be negative 3.
Negative 3? Did you say this?
Yes. Yes.
Did I get you clearly? All right, so
Yes.
negative
That's what
3 is our correct answer. So same signs. Same signs, you do what? Same signs,
add.
you add,
You add.
okay? And get the sign from the bigger number. So this is the same as 2 plus 1. Just a 2, just add those numbers and check the number with a bigger sign, which is on the, check the sign with a which is on the bigger number. So the bigger number here is a 2, which we are going to, 2 is not bigger than negative. Negative 2 is not bigger than negative 1, but forget about the sign and look at the number. Okay? I know negative 1 mathematically is bigger than negative 2. So if you say get the sign from the bigger number considering the signs, we are going to get from 1. But in this case, let's forget about the signs and just look at the number. So negative 2 has got a sign which is negative, so 2 is bigger than 1. So when we say 2 plus 1, what we're getting is 3. So now we don't know which sign to put to add to 3. So you check 2. 2, when you check on the left side of 2, what we have is a negative, okay? So now that is what we need to put there. So negative 1 minus 2, the answer is negative 3. Is it making sense? So
Yes.
those are the many things that you have to know for you to deal with algebraic expressions. Then you are done. The whole topic, almost the whole topic, 50%, it's done. You understand? So let's go.
Mm.
Uh, we have to now. What number is this? What number is that? This one.
This one, it's
This
negative
one, which
2.
is here. Yes,
It's
negative
negative.
2. Yes, it's negative 2 multiplied by x. What are we getting?
You're getting negative 2x.
We are getting
Negative 2x.
exactly negative 2x. Then negative 2 multiplied by negative 1.
Mm. Come again.
Negative 2 multiplied by negative 1. I'm sure you can see this
Negative.
and that.
It will be positive 2.
Positive 2. Yes.
Yes.
I'm glad you've managed to remember those rules. You see? So the rules here, if it was not multiplication and it was something else, it would have changed. Okay, so now here, now since we've dealt with the brackets, we also follow this, this board
Board mass.
mass. bracket order of division. Some people, I don't know what they say, but you know, but this is so we have to deal with the brackets first. So if you have now division, multiplication, and the like, but then what we do have to deal with, and what we dealt with is the brackets first. So now next we need to look at if we've got terms that are like terms. Okay, we do have. So now we write the first one, which is 6x. The next one, 6x is a like term to which term?
2x, negative 2x.
We need to group the like terms. Negative 2x. Okay?
Yes.
Yes. And then next, what are we having?
Mm,
Negative 12
negative 12.
plus 2. Plus 2, right?
Yes.
So, next, what is 6x minus 2x?
8, 8x.
6x minus 2x. Are you sure?
Ah, come again.
6x minus 2x. 6x minus 2x, this expression here
Oh,
is the one
4x.
that we want to deal with.
4x.
4x, okay. Where did you get the
Yes.
8x? Okay, so, one thing I can tell you when you're dealing with mathematics, you know,
Ah,
um, you need to think faster, but don't write faster. You understand? When you're solving, you
yes.
have to calm down somehow. There's how you are supposed to compose yourself. You're getting me?
Yes, I
All
can
right.
understand.
So yes, sometimes we make mistake. Once you make a certain mistake, it will cost you wherever you are going in that on that particular question. You get the point?
Yes.
Mathematics is different from subjects like RE. When they ask you a question, you can even be rushing. Oh, who's Jesus? Or the one who was preaching? Who's Jesus, the Son of God? Both answers are correct. But you find that you can be rushing, you're writing. But when it comes to mathematics, you need to compose yourself in a certain manner so that at least you avoid making silly mistakes, but you still have time to, you know, double check. All right. So negative 12 plus 2. What is the answer?
Negative 10.
Negative 10. Yeah, so that rule has worked. Different signs, you subtract and get the sign from the bigger number. So negative 10. So what's next? Can this be factorized further?
Yeah, yeah. I don't think so.
Okay. All right. So let's do this. And okay. So I like
Ah,
green. Let's do this. Right. So and we move on to the next question. This is from the same topic, question 2. Evaluate negative 2 in brackets raised to the power 0 multiplied by 2 and negative 2 in brackets raised to the power negative 3. This question is trick, huh? This question
yeah.
is a bit trick. How is it? How is it? All right. So uh, there was a question that came the other day. If I remember, it was something like negative 3 raised to the power was it 2 plus,
Mm.
was it again 3 raised to the power 2, something like that. I'll check out the question. There was a lot of debate going on around people, but the question was easy with deep analysis. All right, so this question, um Negative 2 raised to the power 0. Okay. So what is the answer here? So
Huh?
this is paper 1. You're not using a calculator, right? But then what we are going to do here, I've got a certain calculator of which if you say something and then I need to verify, I will use it. You can use a calculator to verify some concepts, you understand? But there are times, but you have to prepare for the exam that particular day. You are not going to use a calculator in paper 1. Are you getting the point? Whilst you're
Yes.
studying, once you find something, you can use a calculator to verify or to confirm a certain concept. You understand? For example, matrices. There are some, I don't know, there are some calculators that are advanced. They can solve matrices, and then you want to verify a certain concept on that particular topic. So you can use it, but you have to be prepared to go and deal with the exam without a calculator. So how do you do? You have to do both things. You solve without a calculator, and again you solve. You just use the calculator to verify or to confirm. All right. So we know that any number raised to the power 0, the answer is what?
1.
Okay. So is negative 2 in brackets raised to the power 0 going to be equal to 1?
Uh,
Okay. So like I said, let me just verify using this calculator. If you also like it, you can get it. It's a very advanced calculator that can help you. So let's do this. Um, that was negative 2, right?
yes.
Raised to the power 0. This calculator, I've minimized it. Would I be able to see? Okay, raised to the power. What I'll do is I will do this and add a 0 here. All right, yeah, right. Okay, so this is the answer. So the same concept still works. So just to confirm, to say even if you have negative numbers in brackets, so long it's raised to the power 0, it will still be
1.
1. But the question is, what if you removed the brackets? What is going to happen? What is going to happen if you remove the brackets and just raise this to the power 0?
If we remove the bracket,
What is going to happen? That's your go and find out. What is going to happen? You should go and find out if nothing changes, okay? So all
yes.
right, so we've got 1 here, which is multiplying by. Now this side we've got negative 2. So we are solving this question because this part is there are some concepts that are found on algebraic expressions that apply to this, but originally this question is under indices. Okay, you get the point.
Yes.
But let's
Yes.
just do it. Okay, so we have negative 2 in brackets, then raised to the power negative 3. Okay, so how do you deal with such? So let's go back to indices. The rules of indices. Of course, we'll look at these questions under indices. Maybe a lot of them um, in details. Okay. So when you say 2 raised to the power maybe 3, this simply means the meaning of this is 2 multiplied by 2 multiplied by 2. You see?
Yes.
This is what it means. So 2 multiplied by 2, we are getting 4, and 4 multiplied by 2, we are getting 8. So it means that 2 raised to the power 3 is what?
You
Is
said what?
8. Okay? I'm saying when you have 2 raised to the power 3, I'm just giving you an example. This is the same as, so it means that this is the base and this is the power, okay?
Yes.
This is the base and this is the power. I'm sure I should not dig deep into this, because this concept which is applying on the other side, it's under indices, and to make you consume different concepts. Maybe should we go ahead, or maybe we should have time to come and just do indices, because maybe I might confuse you, because the whole idea is to make sure that we concentrate on one topic with similar concepts at once.
I think
How is that?
we should do more questions on
Come again?
indices. I'm saying that I think we should
Yeah,
do
so
more
we can
questions
skip
on.
this and deal with algebraic expressions for today, right?
Yes.
Yeah. Okay, so that's basically what we're going to do. All right, so this question, we've got a question here. Factorize completely 27y squared minus 3x squared. Okay, so if you look at the question that just comes here, there are two things. There are a number of things that should come to your mind, but the first thing that should come to your mind is the concept of this.
Differentiate.
This is the difference of what? Two squares. Okay, this is what we call the difference of two squares. Okay, I will explain this, but do you know what we call the difference of two squares?
The reason why you call them the difference of two squared.
Yes. All right. So it's easy. Let me open your mind. Okay. Let me open your minds. People can just mention to you to say the difference of two squares without opening your mind. When you say find the sum, okay, of maybe 1 and 2, okay, what does this sum mean? This sum is symbolizing what? Find the sum of maybe 1 and 2. It's symbolizing what? What is it symbolizing?
Add.
Come again? We add that. So it simply means addition. Okay? Addition. So I want to open your mind. Yes. So we can, the same way we can, if there was such a thing as the sum of two squares, would have been using that. Okay? What if they say the product? Find the product. The product, not the products, but the product. What does this product, when they say the product of maybe 3 and 6, this product symbolizes what? What does this product symbolize? The product here is symbolizing what?
Product
Times. Okay. You better use the term multiplication. Okay, multiplication. What if they tell us to find the quotient? There's also what we say quotient. There's also what we call quotient. Quotient. Quotient is division. Okay. Have you gotten the idea? Quotient is division. Have you gotten? Yes. So now sum, let me just list them. So sum is addition. Quotient is division. Product is what? Multiplication. But we also have the difference. The difference. Yes. It's self-explanatory. The difference is what? Can you know it? The difference. What is the difference? What does it mean? Can you know it?
The difference.
Because these others, they mean those things. But what about the difference? It means what?
Subtraction.
Exactly. So I can even give you a practical example. A practical example is, what is the difference between 4 and 2? It's 2, which means you have to say 4 minus 2. You see, you want to see the difference which is there between 4 and 2, which is 2. Is it making sense now?
Yes.
Mhm. So now when they say the difference of two squares, they're simply referring to a subtraction. Okay? We can even say
Mm.
subtraction of, but mathematical language, we will use the difference. Okay? So now here, when a question, you see terms with the squares, with the terms, with the variables. Okay? So if you have a number like 2, this one is a constant. We refer to it as a constant. Okay? In such things, okay, as a constant. But if you've got something like x, this one is called a variable. Okay, so if variables are squared like
Yes.
that in a question that deals with factorization, you concentrate on the difference of two squares. It might not always be having two terms like that, but you have to use the concepts to be able to solve it. All right. So I'm sure with that in mind, we can now go ahead and deal with this question. Okay. All right. So here, what we are going to do first is let's analyze the question. We've got 27 y squared minus 3x squared. Okay. So now factorizing this, most of the times we need to look for, is there something which is common that can go into both things, whether it is available there or not available. Okay, so here, do we have something that is common before we break it down to deal with the difference of two squares? I guess we
Is
do
there like
have
something which is common that
uh,
can go into both?
yes, that is that can go into 3x squared, and that can go into 27y squared. Is it not a
I
3 itself?
think
So 3, I guess 3,
three,
right?
three itself.
So 3, open bracket, 3 into 27y squared. How many times does it go in there?
Into 27, 9,
Come again? 9.
9.
9, it goes there 9y squared. Okay? Minus,
Yes.
minus what? 3 into negative 3x squared goes there negative x
It will
squared.
be
Is it making sense? Such
yes.
that if you expand
Yes.
this, you multiply throughout, you still go back to that. Okay?
Okay.
Yes. So now here, what we are going to do is we need to have this 9 as a square as well. Okay? So what we are going to do is we'll break it down. 3, open bracket, 3 squared y squared minus x squared. Have you seen? We have we have squares all over. Have you seen? So this
Yes.
is where now we are going to use the difference of two squares. Do you know where the difference of two squares only works? It only works if you've got a negative. Okay? Without a negative, it's not going to work because it cannot go back. Okay? You see? So we've got a negative here. Have you seen this negative which is here?
Mm.
That one. Yes. So the fact that we have that negative, we will be able to work this out using the difference of two squares. Now the difference of two squares goes like this, okay? So 3 outside, open bracket. We just remove those squares and split this into 2. The other one will have a negative and the other one will have a positive. Are you getting the point?
No. Yes.
it will be 3y minus x, open bracket, the other side 3y plus x. What does this mean? This means that if you multiply this and that, it will give you this. Are you getting the point? Because there's no sign here, you see, which means that these two are supposed to multiply for them to give you that. You can do that, it will be able to give you back, to take you back to that. Okay?
Mm.
Have you seen that? Because here we are going to
Yes.
multiply this multiplied by that and that multiplied by that again, this multiplied by that and that again multiplied by that, and then you break it down and not until it gives you back, it takes you back to that. But in a case whereby you had a positive there and then you say let me use the difference of two squares, it's not going to work. So the difference of two squares is just simply, if you've got throughout squares like that, after breaking down something, you can now split it into two like that. Okay? Where you the sign, yes, have you understood this?
Yes, I've understood.
All right, so that's good. All right, so do you have any other question under algebraic expressions? Okay, I guess let's see. Okay, so this is so the equation. All right, so that's under algebraic expressions. Basically, those are the questions that came last year. Okay, so 2024, we are done and talking about algebraic expression. Let's go to 2023. 2023. Let's start with paper. This is paper 2. Okay, so paper 2, we do have algebraic expressions, questions under algebraic expressions. Yeah. So are you able to identify a question which is under algebraic expressions here?
Uh, number 2A.
Number?
Number 2A.
How about number 1A? It's under which topic?
Is it not calculus?
Number 1A. Number 1B is under calculus, yes.
Oh, sorry.
How
Yeah,
about
it is
number 1A?
number 1.
Okay, so
Number
let's start
1A.
with that one. All right. So
Number
if you're good at mastering, okay, there's no space for solving here. So let's master this one. We've got 6, x minus 2, minus 2x minus 4, all right? So hopefully you have a good memory, right? So
A.
from here, all right. So we had 6, x minus 2, minus 2. Let's go. X minus,
Uh,
was it 4?
no, I think it's
Let's check. Yeah, you see? So on, right?
yes.
Yeah. Yeah. So now that is the question. So the question reads, I'm sure, help me read the question. Help me read the question.
I should read the question.
Yes.
Okay, the question says express 6 over x minus 2 minus 2 over x minus 4 has a single fraction in its lowest thing.
All right. So this question, normally people they think it's something new, but then I always tell people to say this is something which is not new. This is actually grade 7 and below work, okay? Sorry to say so, but
Yes,
the concepts that are used here, they are not different. They're just people who like to twist some things here, but this thing is just one and the same thing. When they say, let me take you back, 2/4, maybe plus 3/, maybe, or let's say 6 or something like that. This is the same as 1/2. Okay. So let me put a number, maybe 5 there. Okay. The
uh,
concept we are using here will be the same concept we are going to use here. Which concept do you use here when you are adding fractions or subtracting fractions? You get a common, is it a common, you get a common
common
what?
denominator.
Common denominator, but here you don't have a common denominator, so you find the lowest common multiple, right?
Yes,
Yes, lowest common multiple is found by doing what? Multiplying the two down, right?
yes,
Which is 4 multiplied by 5, right? So when we write 4 multiplied by 5, we can just write them in brackets like that, right? Like if we
yes,
want, we write 4 in brackets and also 5 in brackets, or maybe just 1. Okay? That simply
yes,
means we are multiplying those two, right? I want you to get me
yes,
clearly. And then the next thing is, instead of doing this into that is multiplied by that, we just cross multiply. That is what I basically do. It's one and the same thing, okay?
yes,
Which, if you say, but we'll start with a 2 multiplying with a 5, okay? The one on top here, the numerator
yes,
on the fraction that is on the right hand side, okay? So we'll start with the 2 multiplying with the 5, and then a 4 multiplying with that one, okay? So let's
yes,
go. 2 multiplied by 5, okay? Have you gotten this point? Plus, we
yes,
follow this sign which is here, plus 4 multiplied by that 3 which is there. 4 multiplied by 3, okay? Plus
uh,
4 multiplied by 3, okay? Of
yes,
which is going to give us what? It will give us here 10, right? 2 multiplied by 5, 10, eh? 4 multiplied by 3, 12,
4 multiplied by,
over
yes,
4 multiplied by 20, 5, 20, eh? Then 10 plus 12
5,
is
wait,
what?
20, oh, 22,
20 what?
22,
22 over 20. Okay. So
20,
now here we can simplify that, 22 over 20. There's a number that can go into both. Okay. Which number is that? There's a 2,
2,
2 can go
yes,
in here how many times? 10,
in
into there 11, 11
11
into 10, we can make this a mixed fraction. 1, remainder 1
fraction
over what? 10. Yes. So now,
over 10.
this concept, are you understanding this concept properly?
Yes,
It's the same concept which is being used there. The only thing that these easy sage people do is to add a variable to a certain constant to confuse you. You understand? When you see there's X, you are confused. But it's the same thing. It's the same thing. You just use this concept and you are good to go. What did we have there? Let's just verify. We had one, okay. One, oh, we had what? It wasn't a one. It was a what? What did we have this side? We had a 2 over
wait,
4, right?
uh,
2 over
2 over
4,
5
then
plus 3 over
plus
5,
3 over
3 over
3
5,
over 5. Okay. You see, so this 1.1, we can click here and have more. You see, so these are the answers, okay? 11 over 10, 1.1 in form of decimal, and the mixed number. You see, here we have a mixed number, which is 1 over 10, of which is what we got, not so.
Yes.
So now, let me show you. Let me show you that this concept, if we use it here, it is the same concept. It is the same concept. It's the same concept. Let's get the lowest common multiple of the two terms because they are not common, these ones. They are not similar. Let's say I'm multiplying 1 over 2 and maybe 3 over 2. You just get a 2 because it's a common denominator, right? But then here we don't have a common denominator. We don't have a common denominator. So we'll find the lowest common multiple. How do you find the lowest common multiple? In the previous example, I didn't just want to put a 20 there. I first put 5 and 4 in brackets so that this is going to be important in our next question. These terms, these Ishamrabi. So those terms, these ones, how we are getting a lowest common multiple is just showing them in brackets. If you want, you can multiply them throughout, but it's not important. You understand? It will it will take you long, okay? And it's not necessary. Just showing them in brackets is showing that you are multiplying the two terms, which is finding the lowest common multiple, like we multiplied 4 and 5. Is it making sense now?
Yes.
Now, you get this numerator, okay? To multiply, to cross multiply now, you get the numerator on the right hand side to multiply with the denominator on the fraction which is on the left hand side, to the numerator on the left hand side to multiply with the denominator which is on the right hand side. Are you getting this? So which will be 6 open bracket multiplied by x, okay, minus 4, like that. Have you seen that? And then the sign which we have here is a what? Is a negative, and then we put it there, okay?
Yes.
And then we start with a 2, not to confuse things. We can start with this one, but we start with a 2 to just balance it up and to avoid confusions, okay?
Yes.
And then open bracket x minus 2, like that. That one to deal with that. Have you seen that it's the same thing? It's the same thing that a grade 7 is taught today. You see? It's the same thing. Are you agreeing to say it's the same thing? There's no difference.
Yes.
But did you know that it's the same thing? Did you realize that fact? I'm sure you've come across such a question. Did you realize that it's the same thing? Okay, cool. But for those who don't realize, the only thing that confuses them is the variables. Okay? All right. Um so now let's now deal with the bracket. 6 multiplied by x.
6x.
6x. 6 multiplied by negative 4.
Negative 24.
Negative 24. So okay, the other side, negative 2 multiplied by x, negative 2x, huh? Then negative 2 multiplied by negative 2. What are we getting?
Should be positive 4.
All right, good. Then we just bring our terms the way they are, x minus 4, just like that, and then we'll move on to the next step. All right. So we group the like terms there, but if you want, you cannot show that step, but it's important. Let's show it. Let's group the like terms. 6x minus 2x, okay, minus 24 plus 4, then over x minus 2, x plus, x minus 4. All right, so next, let's just sort them out. There we have 6x minus 2x.
4x.
4x. Then the other side, negative 24 plus 4.
It will give us a negative 28.
Negative 28. All right. Wow.
Yes.
Negative 28. Are you sure? I want you to think about that. Here we have got same signs or different signs. Those rules,
Oh,
they do apply
oh
here.
yeah.
So what's the answer?
Uh, negative 20.
Negative 20. All right. Um, so now we just bring down these ones and x minus 4. Then we are good to go. We're done on this one. So because there's nothing, you know, con this, yeah, there's no, we cannot factorize the top part for us to have something that is going to cancel with any of the terms that are down. So we leave it like that. Okay. So now we have got another question, which is this one here. You know, like this, I want like, you know, it's important to work on this. Helps you improve your memory actually. So like if you can master the whole thing here and just give it to me on the other side without writing down, that would is going to prove that
Mastering
okay, at least somebody, yeah, mastering the whole thing here. 4p
the
over
question.
3q divided by, yeah, this is a simplification question. So 4p minus over 3q divided by p squared q over 6 multiplied by pq over 2. You've gotten it?
Huh?
Okay, let's go. All right, so what I'm going to do is, let me just rub everything. I'll just use this same space here. All right, so we have got, let's go.
So, it is
Uh-huh.
4p
Yes,
over 3q
3q divided by,
plus, well, yeah, it's divided, oh, it was
yeah, it's a
divided by
division. Is divided by,
p, p squared, and then p
come again,
squared, p squared,
q squared, p or
p,
q,
p
p
squared,
squared, uh-huh,
yes, and then q
q over
over 6,
p
over 6,
over what?
6,
P like this?
no, 6,
I'm not getting what you're saying. Okay, let's go. Multiplied by what?
multiplied by pq over 2,
P q over 2. Okay,
yes,
let me just check for what I'm not getting. Maybe I'm not pronouncing it properly. Was this
6,
what you were saying?
yes, 6,
3q and maybe you were you saying 6?
yes,
Oh, okay. Okay, let's just check if what we've written is correct. PQ2. Okay, P squared Q. Okay. Well, at least you've tried. Okay, so let's now go ahead and deal with the question. All right, so you know, board mass is going to work here. So we just have to deal with division first. Okay.
yes,
Yeah. So when you see such a question, they want you to simplify, okay? So now, there's a method where they tell you to say when you see something like 4p, 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 it simply means you've got p, you know, p, another p, another p, another p, okay? You've got about 4p's, okay? 4 of these, okay? And then, yeah, that's the thing. So now, if you say 2p over p, what is the answer?
2p over p.
Yes.
I'm not sure.
The answer is p.
How?
Oh, okay, let me explain. 2p over p, the answer is p. There are 2p's on top and then they are dividing with 1p down, right? So you cannot, this p and, is that
They are
making
cancelled.
sense? Or maybe, okay, let's do this. The answer is not p. The answer is 2. I wanted you to argue, okay? The answer is 2 because the p's are gone, okay?
Okay.
You know, do you know the difference between 4p and maybe p raised to the power 4?
Yes.
You know the difference?
Can I try?
Okay,
Can
so
I
now
try?
let me explain. Okay, let me explain how 2p over p can be expressed. This one can also be expressed as 2p, okay, over 1 divided by or let me say, yeah, divided by p. Have you seen?
Yes.
Maybe p we put also over 1. So now what we can do uh, for us to solve this is we change the sign and say 2p over 1 multiplied by, when we change the sign to multiplication, we reciprocate the fraction which is on the right hand side, okay? And then the p will come down and the 1 will go on top, which means that you can now cancel these ones. Have you seen the concept? Which is the same as just here, okay? Have you gotten the point?
Yeah.
So now, why don't we have multiplication here? We don't have multiplication. Reason because we are dividing two fractions. Are you getting the point? That's why I've used this simple fraction, which can be also expressed as this. It's just one and the same thing. You get the point now? Is it making sense? Uh-huh. So now, talking of 2p divided by p, why the answer is not p, why it's 2, it's because this and that one has cancelled and you remain with a 2, okay? Now, if you had maybe p squared, okay? Let's say you have got p squared, not 2p, but p squared over p. The answer will be p now. You see? Because you've removed one p and then there's one more p remaining there. So which means that when you say 4p, do you have 4p's? You do in which way? That's why I said p plus p plus p, not times. Okay. So when you say 2x plus 2x, you are getting 4x, right? But when you say 2x multiplied by 2x, what are you getting?
4x.
4x, just 4x?
Mm.
4x?
Yes.
Okay. Are you sure? Are you sure?
Mm.
X times x is equals to I want you to understand properly. X times x is equals to what?
X times X. X.
Yeah? The multiplication of variables x times x is equals to what? Is equals to
5.
x squared. But x plus x is equals to 2x. Are you understanding this? But
Yes.
why should 2x multiplied by 2x be 4x?
Okay, it will be
You see?
4x squared.
It, it will be
4
4x squared.
squared.
Now I want you to
Yes.
understand, to say, are you able to hear me? Can you hear me?
Yes,
My
I can
network had
hear you.
tripped for a second. Okay. So have you now understood the difference? Or maybe I should explain more. X plus times x is equals to x squared. X plus x is equals to 2x.
Mm. Mhm.
But I want you to really understand this. Because these same concepts, they will apply at some point. In fact, mathematics, this is mathematics. These are the concepts you need to understand. Okay?
Mm. Yes.
Mhm. So that's the thing. So there's a difference when you're adding, subtracting, dividing, or multiplying these variables. Okay? You have to be very careful. So just by this, you've got a lot of information. X times x is equals to x squared. It's not 2x. Okay?
Yes.
Mhm. And that is why I showed you about 2p, the difference of 2p and p squared. Okay? Eh, You know what it means is if you've got 2p, it means you've got a p plus p. Have you seen? But if you've
Yes.
got p squared, you've got p times p. Okay?
Mm.
Yes. Is it making sense now? So now we can go ahead, having those concepts, we can go ahead and try to conquer this question now. So now the first thing is we are going to change this to multiplication sign, and then
My
we start
network is still the
dealing with.
same.
Oh, I think Enzia choka. From what time? You can see now.
Yes.
But I had written but hopefully you got the point. I had written x times x is equals to x squared,
X squared.
and x plus x is equals to 2x. So this is what I wanted you to understand the difference. Okay?
Mm.
And talking of 2p, the difference between 2p and p squared. Okay? In here 2p, it means that there's a p plus p. But here it means that there's a p times p. Okay? That is why when you've got P squared maybe over, I said over P, the answer is P. But if you've got 2P over P, the answer is 2. You see?
Yes.
Are you getting the point? Yes.
Mm.
So that's the thing. So now let's conquer this question. So we are going to say 4P over 3Q multiplied by, we reciprocate this, 6 over P squared Q, okay? Like that. Then you multiplied by P Q over 2, okay? Are you following?
Yeah.
So now we can I explained, you remember to say, I explained the reason why we are not, this was dividing this, and actually it's still dividing that. I explained where it's coming from. It's because we've got two fractions that are dividing. That is why we added a division sign in between them instead of using a slash, okay? Instead of using this, okay? Are you
Okay.
getting the point?
Mm.
When I explained to say 2p over p is the same as, can also be written as 2p over 1 divided by p over maybe 1, okay? Where we can change this and reciprocate these ones, okay?
Yes.
Have you seen? Have you understood? That is what is happening on top there. You see? There's nothing that we have changed. There's nothing, okay? So, there's a p there and a p, we are remaining with one, with a single p there. And then, okay, and then these 3 into there 1, and then into there goes 2. So we now remain with 4 times 2, we have 8 on top. Follow me properly. I don't want you to get confused, but I want you to follow. Are you following
Yes, I'm
where
following.
these things are going? Yes.
Yes.
So down here we are remaining with q and a single p, but there's also another q there, right?
Yes.
Okay, so which means that these are multiplying. Q squared, we will have q squared, right? We had a q here, right? PQ, it was PQ, right?
Yes.
It was PQ. So we have a
Uh,
q. It doesn't have what to cancel with the other side. So we've got q squared. We're supposed to have q squared. And what number do we have? We have p. We have a
yes.
single p, so pq squared, multiplied by, what do we have on the other side? We've got PQ over 2,
Uh,
PQ over
so
2.
over to
2 into
yes.
2, 1. 2
1,
into 8, 4.
4.
Yeah, yeah. So, so this one will cancel with that one, and we remain with a single Q there, and the P will go with that P. Have you seen?
Yes.
Which means that 4 multiplied by that, we are going to have 4 on top, over what is remaining there. We have a Q.
A single Q.
4 over Q. Do we have any other thing? So this is 4 over Q, right?
Yes.
Yeah. So uh, that's basically it. But this question, you have to be very careful. The moment you make a mistake somewhere, it will cost you. And then you end up finding a wrong answer. So you have to make sure. And if you have time, you go through, you make sure you didn't make a mistake anywhere. Yeah. So that's the thing. Do you have any questions? Because I think we have exhausted our time.
Uh,
You have a question?
no.
All right. So I think we've exhausted our time for today. Yeah. So thank you for being here with me. Uh, I really appreciate and hoping to see you in the next session. All
Yeah.
right.
But
So
even a question.
good night. Come again.
I was saying that you're sending a question for me to answer and submit tomorrow.
You want a question?
Yes.
All right. So you know the way I like giving questions. Um, the way I give questions like this. I will just tell you to take a screenshot, and this seems to be kind of an interesting question, but no, not this one. Okay, let's try something else. Anyways, let's even mark here algebra. We've done it. All right, so 2022 maybe to be interesting. That's algebra. There's okay. There's nothing here. Let me say this one, this one, this one. Okay. Sure. I should find something. 2022 August. Let's see. Okay. But anyway, let me give you one of these three questions. Okay. I'll give you. I'll give you. I'll give you extra questions. Huh?
This one?
Yeah, you can do this too.
I can take a screenshot.
Yeah, take a screenshot of these.
Or
Have you taken a screenshot?
yes.
You should share them in the math group. Are you there in the math group?
Yeah, I'm there.
Not in the
It's
main
this
group, but the math group. Also, this one,
one.
you've taken.
This.
Okay, the last one is this one. So we've got two questions under algebra and one question under equations and another question under indices. So this one as well.
Yes, I have.
Okay, so in total there are about 4 questions that I've given you. So yeah, so thank you for being here and good night.